Hello children, welcome back to 9th standard science class. We have discussed in the last class about mole concept. 1 mole is equal to 6.022 into 10 to the power 23 in number, which is equal to relative molecular mass. Gram molecular mass, sorry. Now, let us work out some problems. I have written a problem here. Calculate the number of moles for the following. When the mass is given, look at here, 52 gram of helium. You have to find mole from mass. Mass is given, you have to find number of moles present in 52 gram of helium. And another problem in the same, 12.044 into 10 to the power 23 number of helium atoms. You have to find the number moles from number of particles. What is given here? Number of particles are given. You have to find the number of moles. Before working out the problem, some terms here you have to remember. And when mass is given, which formula is to be used to find the number of moles, that you have to note. And when number of particles are given, how to find the number of moles, that you have to know first. And then first let us write some terms related to this to understand. Number of moles is denoted by number of moles. N, small letter n. And given mass. Given mass. It is denoted by small letter m. And molar mass. Molar mass is denoted by capital letter M. And number of particles. Given number of particles. Given number of particles. Given number of particles, molar mass is capital M, N, given number of particles, capital N, and Avogadro number of particles. Avogadro number of particles. It is denoted by N0. So first note these terms we use. Number of moles denoted by small letter n, given mass small m, and molar mass capital M, given number of particles capital letter N, and Avogadro number of particles equal to N0. That is considered as N0. Now how to find solution for the problem? Now let us consider the first problem here. What is given here? You know that helium is a monoatomic molecule, so that it consists of only one atom in its molecule. What is the here to work out the problems? We must know the atomic masses of some common elements, children. Here helium, atomic mass of helium is 4U. Atomic mass of helium is 4U. You know the symbol of helium, He, it is 4U. And molecular mass of helium is, or molecular mass or molar mass. Molar mass of helium is 4 gram. And what is the given mass? Given mass, you see here 52 gram. Given mass is equal to 52 grams. So it is small m. Now you have to find the number of moles from the given mass. What formula to be used? Formula to be used is number of moles is equal to N. Number of moles N is equal to given mass divided by molar mass. Molar mass. So what is the formula to be used? Number of moles you have to find. That is denoted by N, I said already. Small n is equal to given mass divided by molar mass. What is the given mass? Means in short you can write N is equal to given mass is small letter m and molar mass is capital letter M. So what is the formula in short now? Number of moles N is equal to M by M. M is given mass, small m divided by capital M is molar mass. That is equal to now given mass is 52 gram. And what is the molar mass? You know it is monoatomic molecule. So 4 gram is the molar mass of helium. That is 4. Means that is equal to 13. So what is the answer here? Number of moles is equal to 13. So this is the first part. See, when the mass is given, how to find the number of molecules? You have to use this formula. M is equal to given mass by molar mass. Means small m divided by capital M. This is the first solution now. Solution for first problem. Now let us go to the second solution now. These terms you remember. Now here what is given in the second problem? Number of particles are given. What are the given number of particles? See here solution for second one. What is given? Given number of particles. What is it denoted by? Given number of particles. Given number of particles is denoted by capital N. So what it is? It is equal to 12.044 into 10 to the power 23. And Avogadro number you know. 1 mole is equal to 6.022 into 10 to the power 23. So now when the number of particles are given, what is the formula to be used to find the number of moles? Now number of moles is equal to number of moles is equal to N. Small letter N is equal to given number of particles. Given number of particles divided by Avogadro number of particles. Avogadro number of particles. So what is it now? Given number of particles divided by Avogadro number of particles. Now, what is given number of particles? In short, the formula is N is equal to capital N divided by N0. N is given number of particles and N0 is Avogadro number. So that is equal to given number of particles. What is given? 12.044 into 10 to the power 23 divided by what is Avogadro number of particles? That you already know the value of Avogadro number 6.022 into 10 to the power 23. When you simplify, this ones are, twos are. So that is equal to how many moles? Number of moles is 2. So N is equal to 2 moles. Did you understand, children, how to use the formula? Let us work out one more problem, slightly different Try to note. And another problem is a worked out example in your textbook that you have to work out. One I will work out now. You have to know the atomic mass of some common elements. Atomic mass will be given sometimes. When you don't know, it will be given. You can easily find. Now another problem, let me write. Calculate the mass of the following. Let us work out another problem. Calculate the mass of the following. Mass of the following. The first one, number of moles given here 0.5 mole of N2 gas. N2 in the sense nitrogen gas. What you have to find here? Mass from mole of molecule. Mole of molecule. You have to find the mass here from mole of molecule. And the second problem is 0.5 mole of nitrogen atom. N atom. Here also mass from mole of atom here. You have to find mass from mole of atom. Third one is 3.011 into 10 to the power 23 number of N atoms. Note the difference between atom and molecule here. Mass from number you have to find here. Mass from number. Number of particles given, you have to find mass. Fourth one is 6.022 into 10 to the power 23 number of N2 molecules. N2 molecules. Here also mass from number you have to find. Mass from number. Number of particles given, you have to find mass from number. In the first problem, you have found the number of moles from given mass and number of moles from given number of particles. Now let us work out the first one. Try to understand the problem here. Number of moles given here. N is equal to 0.5 mole and molar mass you can find. What do you want here? You want the molar mass of N2 gas, means nitrogen molecule has 2 atoms. So its atomic mass of nitrogen is 14 and 2 atoms of nitrogen means what is its molecular mass or molar mass? 2 into 14, 28. So first one let us work out. Atomic mass of nitrogen is 14. So molecular mass of N2. Molecular mass of N2 is 2 into 14, that is 28. Now, how to find the mass from this? You know, number of moles given here. Number of moles N is given. Number of moles N is equal to 0.5. Now, how to find? What is the formula to use? You know already the formula. N is equal to given mass by molar mass. This only now see here number of moles is given and you know molar mass and you have to find mass m here. So change this formula. M we need mass m. Mass m is equal to what? Molar mass into number of moles. So what is the formula? Molar mass into number of moles. Means in short, what is the formula? N is equal to M capital M molar mass into small n. Now molar mass you know we have found here it is 28 into number of moles is given here 0.5 moles. 0.5. What is it equal to? That is equal to 14 gram. Mass is in gram. It is 14 gram. The same way, second one you have to find. Here, nitrogen atoms. You need not find the molar mass into 2 you can't because nitrogen atoms asked. So, atomic mass 14 itself will be considered. Now, second problem is worked out here. See, the same formula is to be used. Number of moles only given. Number of moles n given. How much? 0.5 only. And you have to know the atomic mass of nitrogen. Atomic mass of nitrogen n is equal to 14. Here atoms. So we are not writing 28 here, 14 only. Now what is the mass from this same formula? Mass m is equal to molar mass capital M into number of moles. What is molar mass here? This one 14. Molar mass is also 14. Molar mass of nitrogen is 14 gram. Now m into n, that is molar mass is 14 into 0.5. So how much it is? 7 grams. So what is the answer for second problem here? 0.5 mole of nitrogen atom. It means how many grams? 7 grams of nitrogen. So this is how two problems we have worked out. Now let us consider the third one now. How to work out the third problem. Here what is given? Number of particles given. To find the mass, you need the number of moles also. First you have to find the solution for third one. Find the number of moles first. Find the number of moles. N, you don't know. Here number of particles given. You know how to find the number of moles from given number of particles. N is equal to N by N0. N by N0. Now see 3 point. So what is N given? 3.011 into 10 to the power 23 divided by 6.022 into 10 to the power 23. N by N0. N0 you know already. Then simplify this. Ones are, twos are. Means half mole you got. Means it is 0.5 mole. Now you got N now. Now you can find M mass from this. M is equal to what? Molar mass into number of moles. So you got here the number of moles 0.5 moles. Now you can find the mass from the given moles you have already calculated. Now molar mass. Here see it is N atoms. Means how many atoms? 3.011 into 10 to the power 23 number of N atoms. So here N atoms means already you know molar mass of nitrogen is mass of N atom, that is. So it is 14. So that is equal to what? 14 into 0.5. That is 7 gram. So what you got now? The third answer also 7 gram. You will get it. Now the last one is remaining. In the same way you have to work out. Let us see how to find the solution for last problem. The same type of problem it is. What first you have to find the number of moles. Fourth one, number of moles from given number of particles here. See that the number of particles given. Find the number of moles first. Then you can find mass. So number of moles N is equal to, as I said, given number of particles divided by N0 means Avogadro number of particles. Means what? N is given 6.022 into 10 to the power 23. 022 into 10 to the power 23. It is given number of particles. Avogadro number of particles, you know. 6 value of Avogadro number 6.022 into 10 to the power 23. How many moles? Ones are. So what is the number of moles here? 1 mole you got. Now it is easy to find the mass from given moles. So moles you have N is 1 mole now. You can find now given mass. Mass M is equal to, use the same formula, molar mass M into number of moles. Molar mass here, how to write? See here, molar mass of N2 molecule. Means what? Molar mass of N2 is, mass of N2 is 2 into 14. That is 28. Atomic mass of nitrogen is 14. Molecule it is. So 2 atoms of nitrogen means 2 into 14. So what is the molar mass? 28. So this is equal to now 28 into 1. So how many grams? 28 grams of nitrogen present in 6.022 into 10 to the power 23 number of N2 molecules. So I hope you have understood, children. This is how we have to work out the problems. Same type of another worked out example is there in the textbook. You work out it in the classwork. Now we have completed this lesson. Now let us move on to another lesson. Is matter around us pure? Is matter around us pure? Exercise problems are also there. Try to work out the problems. I will send you the notes and method of working out in the next class. Now let us move on to next lesson. Is matter around us pure? You have learnt already in your previous class. Yes, children, you know that what is meant by a substance. You have seen in the consumables that pure written on the packets. What is meant by that pure substance? Pure substance always consists of only one kind of particles or one type of particles. So can you define what is a pure substance? A pure substance is a single form of matter, or a substance is a pure single form of matter. Can you define the word substance? Substance is a pure single form of matter. Single form of matter. So what is a substance? A substance is a pure single form of matter. Now you have learnt about mixtures in your previous classes. You have to recall this lesson full already. Most of the topics you have learnt in your previous classes. Let us have a glance over them. Now you have learnt about mixtures. What is meant by a augmented mixture? Two or more substances when physically mixed, we call it a mixture. Now see, when salt is added to water, it becomes a mixture. I am adding some salt to the salt to water. See now, you get a mixture now. Yes or no? We get a mixture. And here again, here are iron filings. I make a mixture of salt and iron filings. Look at here, this is also a mixture now. I made two mixtures here. What I did, two substances physically mixed, which is called a mixture. But here see, among these two mixtures, can you find some difference? What difference is there between this mixture of salt and iron filings and mixture of salt and water? Can you find any difference here? Can you find any difference? Look at here, you are not seeing the particles at all in this mixture. Means I added salt particles, but salt particles completely mixed in water. There is no layer of separation at all. Now it is a uniform mixture now. Composition is uniform. Salt and water, two components are there, but the composition is uniform throughout. But look at this. You can see the layer of separation here. Layer of separation in the sense two components also physically distinct parts you can easily see in this here. So that we can classify the mixtures into homogeneous mixtures and heterogeneous mixtures. Homogeneous mixture means what? Here the composition is uniform throughout. Means you don't see the layer of separation here. You are not seeing the salt particles here in this, completely mixed in water, and the composition is uniform. But here there are two distinct physical parts you will see. The composition is not uniform. So non-uniform composition this mixture has. So heterogeneous mixtures have non-uniform composition and homogeneous mixtures have uniform composition throughout. Even though composition may vary, instead of 1 spoon, 2 spoons, if you add salt, composition varies, but the mixture has uniform composition throughout. So these are the differences between a homogeneous mixture and a heterogeneous mixture. Which are the two types of mixtures? Homogeneous mixture and heterogeneous mixture. Homogeneous mixture has uniform composition. Heterogeneous mixture has non-uniform composition. Mixture of oil and water, non-uniform composition. Or mixture of sulfur and salt, or sulfur and soil, sand. These are all non-uniform composition they show. They are all heterogeneous mixtures. Mixture of salt and water, sugar and water, and potassium permanganate and water, they all form uniform composition throughout. So they are all homogeneous mixtures. And difference is there another. There is no layer of separation in homogeneous mixtures found, and there is layer of separation visible in heterogeneous mixture. Let us learn more about what is a solution, what are the properties of solution, and what is a suspension, what are the properties of suspension, what is a colloid, and what are the properties of a colloid, and what are the examples. Let us learn in the next class. See you.